Hello everyone, my name is Karthik Gurjar. I am presenting the solution to question 9 of the end semester examination paper. This solution is submitted to Dr. Shaligram Prajapat sir. Today we will dive into the mathematical core of decision tree, entropy, information gain, and the Gini index. We will apply this concept to the classic Bayes computer dataset to find the best way to split our data. Let's see the data overview. Let's look at our data set. We have 14 records of people with attribute like age, income, and student status. Our goal is to predict if they will buy a computer. Out of 14 people, 9 said yes, 5 said no. This ratio is 9 by 14 and 5 by 14 are the foundation of all our calculation. Let's see the entropy of the dataset. First, we calculate the entropy, which measure impurity or randomness. If a dataset is perfectly mixed, 50 by 50, entropy is 1. If it's pure, all yes, entropy is 0. Using our formula, minus 9 by 14 log base 2, 9 by 14 minus 5 by 14 into log base 2 into 5 by 14. We got a root entropy of 0.940. This high number confirms that our data is currently very mixed. Very mixed. Let's see the information gain of H. Now, we try splitting the data by age to see if it helps. We calculate the weighted entropy for youth, middle-aged, and senior. The average entropy drops to 0.888. This information gain is the difference. The information gain is the difference 0.940 minus 0.888, which is equal to 0.052. This gain is quite low, meaning it does not help us separate the yes-no groups very well. Let's see information gain comparison. We repeat the calculation for all attributes to find the winner. Income gives a gain of 0.029. Credit rating gives a gain of 0.048. Student gives a gain of 0.1152. Since student has the highest gain, it is the best attribute to choose for our first split. Let's see Gini index. Now let's double check using a different matrix, the Gini index. Like entropy, a lower Gini means better purity. For our root dataset, the Gini is 0.459. The Gini index for attributes are, we calculate the Gini index for each attribute split. Age gives 0.436, income gives 0.444, credit rating gives 0.470, student gives 0.367. Once again, student gives the lowest impurity score. Let's see the selecting the best attribute. Let's compare the result side by side. Information gain, student is highest 0.152. Gini index, student is lowest, which is 0.367. Both mathematical methods agree student is the optimal root node for our decision tree. Let's see constructing the decision tree. So how does the tree look? The root node the root node is student. Branch one. Student is equal to yes. Most of these people buy computer, so this leads directly to a leaf node which is equal to yes. Branch two, where student is equal to no. This group is still mixed. We will then look at the next best attribute, which turns out to be age, to continue splitting until we get a pure leaf. Let's see the summary of question 9. To summarize, we started with a high entropy of 0.940. We calculated information gain and Gini index for all features. Both metrics proved that student was the best attribute to start our decision tree. Thank you for listening.